Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from domain of functions, right? And here we have to discuss this problem in which we have to find the domain of the function f of x, which is equal to sine inverse greatest integer of 5 minus 3x. Right, so here we see that we have a function which involves two important functions in mathematics, that is the inverse trigonometric function, that is sine inverse, and the greatest integer function, right? So here we have the combination of inverse trigonometric function and greatest integer function, and we have to find all the valid values of x for which this function is defined, because the domain of functions implies that we have to search for all those values of x, the valid values of x for which the function f of x is defined, right? So let us see how easily we can find out the domain of this function. So here the first important concept is that range of the range of sine inverse theta is given by this interval, that is minus pi by 2 to pi by 2, when this theta belongs to the interval minus 1 to 1, right? So we know that the principal value branch of sine inverse theta is minus pi by 2 to pi by 2, and this is closed interval for all values of theta belonging to this interval, that is minus 1 to 1. So here if we take theta as greatest integer of 5 minus 3x, then this function f of x is equal to sine inverse theta, right? And this theta must belong to this interval. It implies that theta is greater than or equal to minus 1 but less than or equal to 1, right? And our theta is greatest integer of 5 minus 3x. So here we'll substitute greatest integer of 5 minus 3x, and here we have less than or equal to 1, right? So now we have an important inequality involving the greatest integer function. Now let us see how we can solve this inequality. So here we'll make use of this important result, that is, if we have greatest integer of a is greater than or equal to minus 1 and less than or equal to 1, then the value of a, this is greater than or equal to minus 1 but less than 2, right? So when we have greatest integer of a greater than or equal to minus 1 and less than or equal to 1, then this a, which is inside the greatest integer function symbol, then this a is greater than or equal to minus 1 but less than 2. Or in other words, we can say that if greatest integer of a belongs to this interval, that is minus 1 to 1, then this a, it belongs to the interval minus 1 to 2, right? So here I will make use of this important result. So here our a is 5 minus 3x. So we can now form the inequality, that is minus 1 greater than less than or equal to 5 minus 3x, and here we have 2, right? So now we have this simple inequality, so we can now subtract 5 throughout. So we have minus 1 minus 5, here we have 5 minus 3x minus 5, and here we have 2 minus 5. So this is minus 6, and here this 5 and this 5 get cancelled, and we have 2 minus 5, that is equal to minus 3. So now we can divide throughout by this factor, that is minus 3, right? And the direction of the inequality get reversed. So here we have minus 6 over minus 3, and then the direction of this inequality get reversed. Here we have minus 3x over minus 3, and here we have minus 3 over minus 3. So here we'll get now 2, and here we have simply x, and here we have 1. So we can now write this inequality as x greater than 1 and less than or equal to 2. Or in other words, we can say x belongs to this interval, that is 1, and here we have 2, and this is closed, right? So this is open from this end, that is 1, and closed from this end where we have 2. So here 2 is included and 1 is not included. So we see that the domain of this function, it means we have to search for those values of x for which this function is defined, and we have arrived at this result, that is x belonging to the interval 1 comma 2. So the domain of this function is given by this interval, that is 1 comma 2, which is open from 1 and closed from 2. So let us represent this interval on the real number line. So here we have 0, here we have 1, here we have 2. So here 1 is not included, so we can encircle it, and here 2 is included, right? So all the values of x which lies between these two intervals except 1 and including 2, right? So the domain is given by this interval, and here we can easily see that x is equal to 1 is not admissible, because uh, when we take x is equal to 1 in this function, then we can see that f of 1 becomes sine inverse, and here greatest integer of 5 minus 3 times 1, and we have sine inverse, and this is 5 minus 3, that is 2, and greatest integer of 2 is simply 2, because we know that the greatest integer of any integer is given by the integer itself. So we have sine inverse 2, and from here we can see that the theta belongs to this interval, that is minus 1 to 1, right? So here we have 2, and 2 does not belong to this interval minus 1 to 1. So we cannot take x is equal to 1 in our domain. But 2 is included, because if we take x is equal to 2, then we have f of 2 is equal to sine inverse, and here we have 5 minus 3 times 2. So this is sine inverse, and 5 minus 3 times 2 is 6. So we have sine inverse, greatest integer of 5 minus 6 is greatest integer of minus 1. So this is sine inverse minus 1. So this is admissible, because here we have minus 1, and here we have minus 1, right? So 1 is not included, but 2 is included, and all the values which lies in this interval are also included.